Welcome to A2 Object-Oriented Programming. This unit represents the major paradigm shift of your computer science A-level, transforming basic programming into a robust system design methodology. Instead of writing long, sequential lists of instructions, you are going to design independent objects that interact with one another to solve complex problems. This methodology is heavily tested in your Paper 3 theory exam, and it forms the mandatory backbone of your Paper 4 practical coding.
We begin with the fundamental concepts: abstraction, encapsulation, inheritance, and polymorphism. You will learn how to use abstraction to filter out real-world noise, allowing you to design clean blueprints known as classes. From these abstract blueprints, you will write the pseudocode and Python required to instantiate concrete objects in the computer's memory.
Inside every class, you need to define both state and behavior. You will declare attributes to store data and methods to perform actions. You will write special methods called constructors that safely bring your objects to life in memory. Crucially, you will master encapsulation. By applying public, private, and protected access modifiers, you will hide internal implementation details. You will write getters and setters to protect your data from outside interference, ensuring your system remains secure.
Instead of writing identical code twice, you will build class hierarchies using inheritance. As you can see here, a base superclass defines common attributes, and derived subclasses inherit them, extending the functionality with their own specific details. In this section, we will also explore abstract classes that act purely as structural templates and can never be instantiated directly, alongside interfaces that enforce a strict programming contract on your methods.
Next, we tackle polymorphism, the conceptual peak of object-oriented programming. It allows objects of different types to respond differently to the exact same method call. You will learn how to implement this in two distinct ways. First, compile-time method overloading, where you create multiple methods with the identical name but different parameter lists. Second, runtime method overriding, where a subclass completely rewrites a method it inherited from its parent, providing its own specific behavior.
Building a single class is just the beginning. Connecting them correctly is how you engineer a complete software system. You will learn to map out these complex relationships using standard UML class diagrams, which almost always form the starting point for the massive 20-mark coding question in Paper 4. You will distinguish between aggregation and composition to manage exactly how object lifecycles rely on each other. Finally, you will apply classic design patterns to solve common architectural problems efficiently without reinventing the wheel. By the end of this unit, you will have mastered the architecture of modern software. You will be able to design robust classes, implement the 4 pillars of object-oriented programming, and translate UML diagrams into flawless, exam-ready Python code.